Hi, second graders. Today at my house is salad dressing day. What that means is that about once a month I make a couple different kinds of salad dressings that we use on our salads. And as I was getting ready to make it today and pulling out the ingredients, I thought, oh, this is perfect. We're going to do like a cooking show for second grade and make salad dressing, because salad dressing is matter. It is a liquid, and by being a liquid, if I use this vinegar, it is in this shape of a bottle. If I tip it, it moves to fill the shape of the bottle. It tries to go flat. That is something a liquid does. If I look at the properties, which means I use my five senses, I can see that this one is transparent. This is rice vinegar, and it has kind of a yellowish tint. If I look at this balsamic vinegar, which is what I'm going to use today, I can see that it is not transparent. It is opaque. I can see that it is dark in color. And if I open the lid very gently here, I can smell, woo, it is very strong. And I'm going to use this vinegar because it's one of our favorite today. And whenever I measure a liquid, I always use this kind of container. And we're going to put a half a cup, that's to this right here, in our salad dressing. So I'm going to start with a half a cup. Let's see, am I at a half a cup? Let me put it down here. There we go. And then I'm going to put the lid back on that so it doesn't spill. And look, we have a half a cup of this vinegar. If we look, it moves to take the shape of this container now. And as it moves, I'm going to take it out of here and I'm going to pour it into a container with a top that I'm going to be able to seal. So I've just got a regular jar with a nice tight fitting lid. I'm going to take the lid off and I'm going to pour. Now, what do you predict will happen with this when I pour it into there? Think about it for a minute. Okay, because it's a liquid, when I pour it in, it is going to change its shape. Did you notice that it changed its shape? It looks now like the shape of this glass. And I'm going to set that down and just put the lid on it for just a second so it doesn't spill. Next thing I'm going to add to this vinegar is another liquid, and then we're going to examine these two liquids together. I have a jar right here that I brought because I couldn't bring the sink. This is just plain water. Do you notice the properties of this water? It is transparent. I can see you. Kind of blurry, but I can see you. It flows. It tries to go flat because it's a liquid. Now I'm going to take the lid off of this one, and this time I'm going to use a measuring spoon, and I'm going to, this is a tablespoon, and I'm going to put 3 tablespoons of water into my vinegar. So here's my vinegar. It's opaque. Here's my water. It's transparent. See the difference? Let's see what happens when we put the two of them together. Now I'm going to hold this up so you can see it. But okay, I've got 1 tablespoon, 2 tablespoons, 3 tablespoons. Now, did you notice something when I added it? Look at these bubbles. If you look around the edge, there's some bubbles. The bubbles around the edge are caused because of the air that went in with the vinegar. But did it change? Is this still transparent? Is this still opaque? Let's shake it and see if we can change it. Let me get the water out of the way. So this is the vinegar in the water. Shake, 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 shake. Oh, lots of bubbles. Yeah, there we go. Lots of bubbles with the air. But is it still opaque? Yes. Is it still brown? Yes. So the water didn't change it too much. But now we're going to go to our next liquid. I'm going to set this off to the side, and I'm going to bring this up. And in our next liquid we're going to add is oil, because this is just going to be an oil and vinegar dressing. And I'm going to use this olive oil, and this is actually a garlic olive oil, but it's still olive oil. And if you look, it is still a little bit transparent. So we would say this one is translucent. Do you see the difference? I can see through it, but it's not like when the water. Here's my water from earlier. See? You can see perfectly. This one you can't so much. It's a little, this one is translucent. If I were to use a different kind of oil, which I didn't bring over, it might be a different color as well. Your salad dressings take on whatever taste that you like, so you can experiment with different oils and different vinegars. Just remember, it's 50% vinegar and 50% oil, and then a couple tablespoons of water. Now, when I pour this, I'm going to want a half a cup, just like I did with the vinegar, and I'm going to get it to a half a cup. There we go. There's a half a cup. If I look at that, when I poured it, did you see that that poured slower? Do you see that it is a little bit sticky on the side of the container? If I smell it, whoa, I can kind of smell the garlic in that. It's a little strong there. But because it kind of sticks to the side, one of the properties we say for this particular kind of oil, is that it is viscous. Viscous means sticky, slow moving. Because we're going to pour this, let me put the lid on the other so it doesn't spill. We're going to pour this into our balsamic vinegar and water earlier. Now, do you think it's going to change color? Make a prediction. Got your prediction? Now I'm going to pour this. Watch how much slower it pours than the olive oil it did. Do you see how much slower it's pouring? Now, as I pour this into my vinegar, you see something happening? If you look at your, I'm going to hold it up a little further. Look what happened. Where'd the oil go? This is the oil. This is the water. Excuse me, this is the vinegar. And actually, if we let it sit long enough, you would see 3 layers. You would see the oil, then you would see a layer of water, and then you would see the vinegar. The reason for that is that different liquids have different weights, different viscosities on how slow they move, and they all have obviously different chemicals. But because oil is lighter, it floats. That's why when there's a wreck of a ship and the oil and the gas float on the top of the water, because it has a lighter viscosity and it goes up. So in order to get this to mix up with the balsamic for my dressing, I have to shake it or mix it. So I'm going to put this together. Now think about what kind of properties we're going to see when this mixes together, because now we have made something brand new. So shake, 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 shake. And I'm only going to shake it for a few shakes now. If you do this at home, you'll have to shake it every time you use it. Some people like to put a solid sugar in it. We don't put the sugar in ours, but some people do. Then if you do that, that would be a good extension. What do you think would happen? Would the sugar mix up with it? Would the sugar become a liquid too? And there. Did it mix together? Yep. Look at the side. You see how the oil's made the viscosity? Uh-oh, watch what's happening. You see another property here? It's bubbly. Do you see the bubbles along the top? Try this at home. Make sure you have your parents' permission. I'll put my recipe on the classroom, and you can try that, or you can try your own. I'll put the sugar in it optional. We don't use sugar in ours, but you might want a little sugar in yours, how the original recipe is. Sometimes people put other vegetables in it, like chopped up onions or chopped up nuts or chopped up other things. This is my basic recipe. I will go on and I'll make a different salad dressing later this afternoon. But bon appetit! hope you make a liquid salad dressing. Pay attention to the different properties and how it is different than a solid.